This panorama from Curiosity Mars rover shows geological members of the Yellowknife Bay Formation and the site where Curiosity drilled into several rock targets. The rocks here record superimposed ancient lake and stream deposits that offered past environmental conditions favorable for microbial life. Rocks here were exposed about 70 million years ago by removal of overlying layers due to erosion by the wind. Curiosity Mars rover imaged these drifting clouds using its black and white navigation cameras. These are likely water ice clouds about 19 miles above the surface. They are also noctilucent clouds, meaning they are so high that they are still illuminated by the sun even when it's night at Mars's surface. Scientists can watch when light leaves the clouds and use this information to infer their altitude. A field of sand dunes occupies this frosty 5-kilometer diameter crater in the high latitudes of the northern plains of Mars. Some dunes have separated from the main field and appear to be climbing up the crater slope along a gully-like form. The surface of the main dune field here is characterized by a series of dark-toned polygonal patterns which may be the result of seasonal frost processes. We can also see that several of the steeper dune slopes pointing in the downwind direction host narrow furrows suggesting the start of gully formation. Also seen here are crater floors containing a variety of textures including lobate and striped patterns that indicate seasonal thaw caused by sublimating ice. This panorama looks outward in every direction from the top of Husband Hill. The summit of Husband Hill is a broad plateau of rock outcrops and wind-blown drifts about 300 feet higher than the surrounding plains of Gusev Crater. When this image was taken, the sky changed in color and brightness due to atmospheric dust variations as seen in contrasting sections of this panorama. Haze occasionally obscured the view of the hills on the distant rim of Gusev Crater 50 miles away, and dust devils swooped across the horizon in the upper right portion of the panorama that appear red, green, and blue. As a result, the whole panorama allows viewers to observe weather changes on Mars. This image taken by Curiosity Mars rover shows an amazing landscape. The rise, topped by two grey rocks near the center of the image, is called Twin Cairns Island. It was about 100 feet from Curiosity's position when this image was taken, and the two grey rocks combined are about 10 feet wide. The bright, loose material seen here was discovered along the floor of the basin south of Husband Hill in Gusev crater. Mars rover uncovered several types of materials distinctive in their color, physical properties, and chemistry as a result of digging a trench in the area. The white material in view is brighter than any seen previously by the rover and has a powdery and cloudy texture which exhibits a high abundance of salts. Scientists hypothesized and then confirmed that these materials have a salty chemistry dominated by iron-bearing sulfates. These salts may record the past presence of water as they are most easily mobilized and concentrated in liquid solution. The rover also examined the unusual pitted rock about 4 inches wide in the lower center of the frame in order to understand the origin of these rocks and soils and the role that water has played in their formation. The rippled surface of a high Martian sand dune fills this view. This site is part of the Bagnold Dunes field along the northwestern flank of Mount Sharp. The dunes here are active and migrate up to about 1 yard or a meter per year. This image shows a late afternoon view eastward across Endeavour Crater on Mars. Endeavour Crater spans 14 miles in diameter, or about the same area as the city of Seattle. The interior basin of Endeavour is in the upper half of this view. This image from Curiosity rover shows a rock outcrop that pops out from a Martian surface that is elsewhere blanketed by reddish-brown dust. The fractured outcrop also has blocks of exposed, clean surfaces and rounded gravel fragments or clasts up to a couple inches in size in a matrix of white material. Many gravel-sized rocks have eroded out of the outcrop onto the surface, particularly in the left portion of the frame. The outcrop characteristics are consistent with a sedimentary conglomerate or a rock that was formed by the deposition of water and is composed of many smaller rounded rocks cemented together. Water transport is the only process capable of producing the rounded shape of clasts of this size. Curiosity Mars rover took this image when it was overlooking a shallow depression called Yellowknife Bay, which is in the left third of this image in the middle distance. Yellowknife Bay is a 5-meter geologic depression located in the large impact crater known as Gale Crater. The Mars Reconnaissance Orbiter has observed morphological features created by the presence of liquid water at this site, suggesting the presence of an ancient lake which could have sustained microbial life here. Perseverance rover took this panorama at Van Zyl Overlook, where the rover was parked for several days as the Ingenuity helicopter performed many of its flights. A cloud of particles puffs upward at a steep cliff in this image from NASA's Mars Reconnaissance Orbiter. This is the result of an avalanche or fall of mostly carbon dioxide frost. According to NASA, this sort of event happens mainly during the planet's springtime, which roughly corresponds to April and early May on Earth. This panoramic image shows a group of boulders at a basin south of Husband Hill. These basaltic rocks were formed by volcanic processes and they are located on a vast plain covered with solidified lava that appears to have flowed across Gusev crater. The basaltic rocks are interesting because they exhibit many small holes or vesicles similar to some kinds of volcanic rocks on Earth. Vesicular rocks form when gas bubbles are trapped in lava flows and the rock solidifies around the bubbles. Then when the gas escapes, it leaves holes in the rock. The quantity of gas bubbles in the rocks at this location varies considerably, as some rocks have none while some, such as several here, are downright frothy. The change in textures and the location of the basalts may be signs that they are located along the edge of a lava flow. The large size and frothy nature of the boulders might indicate that eruptions once took place at the edge of the lava flow where the lava interacted with the rocks of the basin floor. This image taken by Curiosity rover highlights the interesting geology of Mount Sharp. Prior to the rover's landing on Mars, observations from orbiting satellites indicated that the lower reaches of Mount Sharp are composed of relatively flat-lying strata that bear hydrated minerals. Those orbiter observations did not reveal hydrated minerals in the higher overlying strata, however. The mastcam data from Curiosity has revealed a strong discontinuity in the strata above and below, agreeing with the data from the orbit. This provides independent evidence that the absence of hydrated minerals on the upper reaches of Mount Sharp may coincide with a very different formation environment than lower on the slopes and show an area where the process of sedimentation stopped.